we can talk about acid-base titrations. We've all done acid-base titrations before, and normally what we do is we have a suitable indicator, we add our base to our acid, and we wait for an end point. And the end point is when the colour changes. So today we're going to do something slightly different. It's very, very similar, but it is different. We won't be looking for endpoints because we're not going to talk about we're not going to talk about titrating using a indicator. We're going to use something much more reliable, something much more high tech, and it's one of these. So this is just a pH probe. It's a relatively simple bit of equipment. All you have to do is if you put this into your solution and it's connected to a data logger, or just even if it's just like a screen, it will tell you the pH. And then what we can do is we can log pH. And if we can start writing down, well, we can write down our pH, and then we can get what's called, we can get our graphs. And there's 4 graphs that we need to know about, and we need to be able to use one. So, there's going to be 4 different combinations. Because we've got our strong and weak acids, our strong and weak bases, there's going to be 4 combinations of graphs that we need to know about. And we are always, in our graphs today, we are going to be adding the base to the acid. So I always remember as the base is dropped. Right, so our axes, so down here is volume of base. So it might be sodium hydroxide, potassium hydroxide. Most hydroxides are actually strong. And then we've got our ammonia is our weak base. We're not going to be looking at our weak base right now. And on this side we have pH. So if I have a weak base and, we're going to go through strong acid and strong base. That's our first graph that we're going to look at. And if you were to start with your strong base, or very strong acid, there's the last colour. Because it's a strong acid, we're going to stop around here. And because it's a strong base, so our pH, we're going to go from about 7 is going to be there. So this is 0, this is 14. So our strong acid starts here, and our strong base is going to end up here. And what we're going to do is our shape of our graph, as we start adding the base, the pH isn't going to change much at all. This is volume of base. So at the start, when we've added 0 volume of the base, so say our base is, we're going to pick a strong base, so sodium hydroxide. So as we add 0 sodium hydroxide, the pH is going to be about 1-ish, because it's a strong acid. And as we add more base, what's going to happen is the pH is going to change very, very slightly, maybe not at all. And then suddenly, it's going to go up like that. And our pH will suddenly change. And what we can do is we can look at this line here. This line here is what we call the equivalence point. So the equivalence point is when the OH minuses, if it's an alkali, and the H pluses are effectively the same amount. So at this point here, so the equivalence point, we've got our H pluses concentration is equal to our OH minus concentration. So what we might want to do is we could draw a line through that equivalence point. And that equivalence point is when the solution is neutralized. So if we were performing this titration and we were adding our base and we were using the pH probe, when we see this graph effectively have this straight line, that's our equivalence point, that's H plus equals OH minus, and that's when we can use the volume of base to work out the concentration or the amount of moles of the acid. So if we were thinking back to kind of year 12 or maybe year 11 titrations, this would kind of be your end point, but we don't call it your end point because your end point is when the colour changes or when your indicator changes colour. This is the equivalence point, so where H plus is equal to OH minus. That's why we've got pretty much at pH 7 has changed. But so this is the point where you would use the volume of base to work out the amount of substance of base. Then you can work out the amount of substance for your acid, and then you'd be able to work out your concentration of acid. So the other graphs that we need to know, so we've got strong acid, strong base. So what we're going to go for now is we'll go for strong acid and a weak base. So if we were to draw our axes, we can kind of predict where it's going to be anyway. So again, this is volume of base. I imagine the only weak base that we are going to meet is ammonia. So again, this is my pH, 0, 14, 7. So when I'm drawing on my line, I've got a strong acid. So I'm going to start here. My weak base is probably going to only be about 8 or 9. So when I'm drawing this, again, same thing happens. We do get that kind of extreme curve here, it's a little bit less here. So we can still have our equivalence point, and we can work out our concentration of H plus ions. So that's strong acid and weak base. So now we can draw a weak acid. So your weak acids, they're probably going to be your carboxylic acids. So weak acid, and we're going to have a strong base. So again, we're going to draw our axes. Again, volume of base, because we are dropping base. And we have our pH, 0, 7, 14. So this time it's going to be a weak acid. So it's probably going to be about pH 9-ish. So we're going to start about there. Our strong base is going to be about 14. And what happens is you get the same thing. That's not very good. So when you draw these, you realistically, for these three, you want a very nice kind of vertical equivalence line. That will make life much easier later on. So we've got a nice vertical line. So there's our equivalence point. You can work that out. And then we can use that equivalence point similar to an end point. And again, we can work out amount of substance for base, amount of substance for the acid. Then you can work out pH, etc. So all of those are really lovely. And then we get our final graph. Our final graph is weak acid, weak base. I'll keep it. So if we've got our weak acid and weak base, we've got our normal axes. So again, volume of base. We can have pH. That's going to be 14, 7, 0. So now we've got, this one is slightly different to the other three. Because we've got weak acid, we've got weak base, the curve is a little bit like that. There is no good equivalence point on your weak acid, weak base. It's very, very difficult to find that equivalence point. So at this point, you wouldn't bother. If you've got a weak acid and you've got a weak base, you would perform a back titration. Back titration is something we worked out a long time ago at the start of year 12, where you would add a strong acid or strong base to your weak base or weak acid, and then you would calculate how many excess moles of acid or alkali you've added. Purely because this, you can't use your pH probe to work this out. And later on we'll talk about indicators. you'll realise why we can't use indicators for this either. They're the 4 graphs we need to know, and we need to know the equivalence point is the point at which the concentration of H pluses is equal to the concentration of OH minuses. That's similar to our endpoint. We can then use the volume of base to work out the amount of substance of base, and then we can work out the amount of substance for the acid, and you could work out your concentration of your acid. Right, so we're going to do a task. You're going to do task 11 in your booklets. So task 11 in this booklet, and then I want you to do the summary questions on page 327 in your books. Any questions, please do ask.